The more we learn science, the more we understand the universe. Hello, science folks! Welcome to a new episode of Bamboo Telescuela. This is Teacher Richie from Kawayan City National High School, Marabulig Extension, your designated teacher on air. Together, we will get to understand the universe, particularly force and motion, through Science 7. Before we begin, make sure you have everything you need for this lesson, like your pen, paper or notebook, and self-learning modules. Stay tuned in to any of the following: SDO Kawayan City Live, 88.5 DWND FM, 1107 BWDY AM, or CMD Cable Channel 11. Now if you're all set, it's time for Agham Learning. Learning science at the comfort of your home. Many of the things around us move. Some move slowly, like turtles in clouds. Others move much more quickly, like satellites and bullet trains. Because motion is so common, it seems to be very simple. But in science, describing motion actually entails careful use of some definitions. Today's episode will help you describe motion in terms of distance and displacement. In particular, you are expected to differentiate these two quantities that describe motion and find out the distance and displacement of an object. Are you ready? Great! Before we describe motion, let us first refresh ourselves with what motion is. Look around you. What moving objects can you see? Perhaps me if you're watching. Or if you are tuning in outside, the leaves swayed by the wind. But the question is, can every moving object be considered in motion? When can we say that an object is in motion? In the simplest sense, motion is the act of moving. But science-wise, motion is defined as the change in position or location of an object with respect to a frame of reference or reference point in a particular time interval. What is this reference point? Reference point or frame of reference is a place or an object used for comparison to determine if something is in motion. An object is in motion if the position is changing in relation to a reference point. For example, in a 100-meter race, the reference point is the starting line. A runner changes position as soon as the race starts and he gets away from the starting line. If there is a change in position, the runner is in motion. Can you follow? Great! Let's take another situation. A ball rolling. Is it in motion or not? Very good. It is in motion. Why? Because once a ball rolls, its location is changed. How do we say that its location or position has changed? We consider a reference point. Our reference point is the initial location of the ball before it rolls. Did you get it? Good job! But remember, motion is relative. Whether an object is moving or not also depends on your point of view. It is relative to either the reference point of the observer or to another distinct reference point. For instance, a woman riding on a bus is not in motion in relation to the seat she is sitting on. But she is in motion in relation to the buildings the bus passes by. To simply put it, if our reference point is the seat where the woman is sitting, then she is not in motion. If we consider the buildings the bus passes by as our reference points, then she is in motion. Now, there are different ways to describe motion. And we can start describing it by answering the question, how far did the object travel? Do you miss going to school? I'm sure you all do. Before the pandemic, how far did you always travel to get to school from your home? Not that far? So far? Very far? Quantitatively, there are two ways to answer this question. One is through distance, the other is through displacement. To give you a distinction between the two, let's consider this situation. Cecily's school is not that far away from her house, so she only travels by foot. Every day, she walks 50 meters east, then heads 25 meters north. She reaches her school by taking on another 50 meters west. How far does Cesa travel daily from home to school? First, let us get the total length of the path she covers in going to school. To understand it better, let's draw an illustration based on the given situation. You may also draw your own illustration in your notebook. In the situation, she goes 50 meters east. Remember, east is going right. Then, 25 meters north, which is upward. Then, 50 meters west, which is going left. So our illustration looks like this. If you add these numbers up, 50 meters, 25 meters, and 50 meters, Cesa has traveled a total of 125 meters. This measurement gives us the distance. From that, we can describe distance as the length of the entire path that an object has traveled at a particular time interval. So, in getting the distance, you are going to consider all paths covered by an object. Take note, distance is a scalar quantity. That means we are only going to need the length traveled by the object. This time, let us get the measurement of the straight path between Cesa's original location and her destination. Again, let's make an illustration. In the situation, her original location is her house. She then walks 50 meters east, then 25 meters north, then another 50 meters west, until she reaches her destination, which is the school. Remember, we are finding the straight path length from her original location to her destination, which is from her house to her school. So, let's connect them using a broken line. Notice in the illustration that Cesa's school is just 25 meters north from her house. Therefore, Cesa has traveled 25 meters to the north if we will only consider the straight path distance from her original location to her destination. This measurement now gives us the displacement. From that, we can describe displacement as the shortest distance between the initial and final positions of an object. So, in getting the displacement, we only have to consider the initial and the final location of an object no matter what path it takes to get to the destination. Take note, displacement is a vector quantity, meaning it has both the length and direction. Can you follow? Alright, here's another situation. Charity went to Donna's house, which was only 100 meters east from her house. Then, she remembered to stop by Janine's house, which was 50 meters west from Donna's house. After that, she went on 60 meters west to Sayan's house. What is the total path length traveled by Charity? And what is the distance between her initial and final position? What is the first question asking? Yes, it is asking for the distance. How do we get the distance again? Correct! We will just add up all the path length covered by the object. Now, let's draw an illustration based on the situation. Start with 100 meters due east, 50 meters due west, and 60 meters also due west. Now, we will add up the values 100 meters, 50 meters, and 60 meters. So the distance will be 210 meters. Now, for the second question, it is asking for displacement. How do we find the displacement? Excellent! We will just have to get the measurement of the shortest distance between the initial and final position of the object. Let's use the illustration we have drawn earlier. Where's the initial point again? Yes, it is at Charity's house. How about the final point? Very good. It is at Sayan's house. This time, let's connect the initial and the final points using a broken line. This is now our displacement. But what is its magnitude? Remember, Charity traveled 100 meters east, which is going right. Then 50 meters west, which is going left. She traveled another 60 meters due west. Are we also going to add the values up? No. But why? Because they have different directions. So, for our solution, it will be 100 meters east, then subtract 50 meters since it is due west, which is in the opposite direction. Then, subtract another 60 meters because it is also due west. Our displacement is negative 10 meters. Take note, the negative sign already indicates the direction. Negative sign signifies that the motion is toward west or south. So, you may also write the displacement as 10 meters to the west. Why to the west? Because the direction from Charity's house to Sayan's house is westward. Are you catching up? Let's have another one. A ball rolls across the floor 3 meters to the right, then rolls another 1 meter in the same direction. What is the distance and what is the displacement? For the distance, it is 4 meters. Since we are only going to add up the values, 3 meters and 1 meter. How about the magnitude of the displacement? That's right. It is also 4 meters because the values are in the same direction. What is the direction of the magnitude then? Correct. It is to the right. So, the displacement is 4 meters to the right. What have you noticed about the distance and the displacement in the given examples? From the given examples, we can infer that distance measures the length of all path traveled by the object. It does not always follow a straight path, while displacement measures the length of the straight line that connects the object's point of origin and its point of destination. It always follows a straight path. Another, distance does not depend on direction, whereas displacement depends on direction. Also, distance does not decrease. It can never be zero or negative because it is a positive scalar quantity and does not depend on direction. So the values are additive. Meanwhile, displacement may decrease. It can either be positive or negative. It can also be zero depending on direction. Alright, can you now tell the difference between distance and displacement? Then, it's time for a checkpoint. Try this example. A man walks 5 meters forward, then walks 2 meters backward. Find the distance and the displacement. You have 2 minutes to do it. Time's up! Let's see if you got it right. What is the value for distance? Correct! 5 meters plus 2 meters equals 7 meters. What about displacement? Brilliant! 5 meters less 2 meters is equal to 3 meters. Why did we not add the values? Yes, it is because they are in the opposite direction. What is the direction of the displacement then? Exactly, it is forward, which can also be north. Great work, grade 7! Give yourselves 2 thumbs up for a job well done. See, learning science has never been this easy. Now, it's time to put what you have learned to use. Get your learning activity sheets and answer the activities provided. If you have any question or clarification, you may reach your Science 7 teacher through text or messenger or in any way possible. That wraps up our lesson for today. I hope you had a great time learning science. Remember, the more we know, the more we grow. Again, this is Teacher Richie leaving you with words. If life is a motion, distance is a journey, and displacement is the result. I'll see you next week for another Agham Learning. So long!